Good days. Our group is composed by Kevin Trujillo, Jenny Hostos, Daniela Ramos, and Adriana Velasco. We are going to explain an exercise of analysis sensitivity. Example. In a pastry, we'll make two types of cake, cake 3 meals and cake trifles. Each cake 3 meals needs the quarter or filling and 1 kilogram of cake and produces a profit of 5,000 pesos, while a truffle cake needs half a kilogram of fills and 1 kilogram of cake and produces 8,000 pesos of profit in the pastry is gain of the daily and total 150 kilograms of sponge cake and 50 kilograms of stand, although probably machinery cannot do more of 125 cake of each type. How many cups of 3 meals and cake for muscle to the day to the maximum type benefit? It's 1. Equal quantity of 3 meals cake to be sold per day. It's 2. Equal quantity of truffle cake to be sold per day. Objective function is C maximum 75,000 multiplied it's 1 more 8,000 multiplied it's 2. We created a table reflecting all available information to better visualize the restriction of the problem. The restrictions are as follows. According to the we make the graph, I had the coordinates of the vertices that are part of my feasible area. With the replace coordinates in my target to connect the maximum C resultados. The maximum C is the largest result. Replace the objective function and clear S1 and S2, giving the points in which we must make the line where intersect with existing line is my feasible solution.
Correct objective function C1 x1 plus C2 x2 C1 divided C2 same and then or C2 divided C1. The number must be different from 0. We find C1 and C2 of M1 and M2. The equation from which the terms are chosen are thus terms intersect with the solution. Substitute the values of the equation in a slope equation. It is located, then if it is necessary, then clear the denominator. The value of C2 we find in the object function is equal 8,000. We replace, we do the same with the equation C2 divided C1. Here locate, then if it is necessary, then do the denominator. The value of C1 we find in the objective function is equals 4,000. This means that x1 same 1, I can vary from 4,000 to 8,000. It's 272. I can vary from 5,000 to 10,000.
Change in the availability of resources. Find the amount of resource bond F. Find the amount of resource bond H. Is replaced in the equation of M1 with is a quarter multiplied S1 plus a half multiplied S2. F sum a quarter multiplied 150 and 50 plus a half multiplied 0, it sum 75 million. A sum a quarter multiplied 25 plus half multiplied 125 is sum 275 divided into 4. Resources M1 going to be moving between 75 million less or equal M1 less or equal to 175 divided into 4. Find the amount of resource point D. Find the amount of resource point A. Is replaced in the equation of N1 which is S1 plus S2. This sum 125 plus 75 million is sum 325 million. A sum 0 plus 100 is sum 100. Resource M2 is going to be moving between 100 less or equal M2 less or equal 325 million.
Analysis the price chart. A yi equal chain of C value corresponding to feasible interval I. Feasible resource interval I. Derived a y1 equal chain of C from F to H check and 1 of F to H. Substitute in the objective function of the problem. C equal 5,000 x1 plus 8,000 x2. CF equal 5,000 multiplied 150 plus 8,000 multiplied 0 equal 750,000. C equal 5,000 x1 plus 8,000 x2. CH equal 5,000 multiplied 25 plus 8,000 multiplied 125 equal 1,125,000. Replace in the equation y1 y1 equal 1,125,000 less 750,000 divided 207 divided into 4 less 75 means is some 12,000. y2 equal change of c from the to a divided change in 2 of the to a. Substitute in the obvious portion of the problem. CD equal 5,000 multiplied 125 plus 8,000 multiplied 75 medium equal 925,000. CI equal 5,000 multiplied 0 plus 8,000 multiplied 100 equal 800,000. Replace in the equation y2. y2 equal 925,000 less 800,000 divided 325 medium less 100 equal 2,000 less 100.
We have the equation in primal forms. We pass into dual forms use. Have u1 equal 12,000, u2 equal 2,000, u3 equal 0, and u4 equal 0. u3 equals 0 and u4 equals 0. One way to check in the values the problem be simple and we stack the date of the last iteration in brackets. We place the values of the objective functions and in another brackets the date of the last iteration of simples. Then we multiply with 5,000 for minus 4 plus 8,000 for 4. And so it and we have as a result EQ 12,000, X2 equal 1,000, X3 equal to 0, X4 is 4 equal to 0, C equal to net.
In Excel, I place the function of the type and hold on, I create the next table. I hold X1 and X2 result thing and in the side right. In the column 8, I start to write function objective. R1, do reference of a restriction number 1. R2, do reference of a restriction number 2. And suitably, R3 and R4. I place in the side down the variables and